We apologize if you've experienced any issues logging in. We've learned that a lot of the circuits are overloaded, so we appreciate your perseverance to join us for the webinar. My name is Kurt Smith. I'm with Applied Pavement Technology, and I'll be serving as your host for today's webinar on pavement end-of-life considerations. This is a part of an ongoing series of webinars on sustainability that were developed under the FHWA's Sustainable Pavements program and covers all stages of the pavement life cycle. Before we get started, I wanted to mention just a few housekeeping items. This webinar is scheduled for a total of 1 hour, consisting of an approximate 45-minute formal presentation and a 15-minute question and answer session. The questions will be answered at the end of the formal presentation, but you may submit your questions at any time during the presentation using the questions box on your control panel. If you don't see the question box, you may need to click on the orange arrow icon on the control panel to display the settings, as shown in the figure on the screen at the upper right. At the end of the session, we will work to answer as many of the questions as we can within the time allotted. For those questions that we do not get to, the panelists will prepare and post responses to all attendees, and we will notify you when those become available. After the conclusion of the webinar, a copy of the presentation will be shared with all registrants via email, along with a link to the webinar recording once it is processed. You may need to regularly monitor your spam or junk folders, as we're finding that there are some of our webinar communication for the registrants occasionally gets redirected there. Throughout today's webinar, we will be using a number of acronyms referring to different materials, products, and processes. We'll work to introduce these as they are used during the actual webinar, but this master list will be available in the presentation that we will share with you later. With that, I would now like to introduce Ms. Monica Urado with FHWA, who will preface our webinar with a quick look at FHWA's Sustainable Pavements program.
Good morning and good afternoon to some of you. I would like to welcome you to the Sustainable Pavement Systems, the webinar series. Today's webinar will be on the pavement end-of-life considerations, and our presenters for today will be Tim Aschenberner and Rick Menninger. Before we get started, I would like to let you know a little bit about the FHWA Sustainable Pavements program, which began in 2010 with the vision and mission to advance the knowledge and practice of designing, constructing, and maintaining more sustainable pavements through stakeholder engagement, education, development of guidance and tools. Some of those tools would be the Sustainable Pavement Systems, the webinar series. Today is the 6th of the series of 10 webinars. You will receive 1 professional development hour per webinar, and upon the completion of 8 out of the 10 webinars, you will receive a course completion certificate. The Sustainable Pavements program also developed the FHWA Sustainability Ambassadors, which is a group of FHWA employees from different disciplines whose goal is to expand the knowledge and outreach within their field that complements the Sustainable Pavements program. From today's webinar, you could learn what is end-of-life considerations and how they are related to pavement sustainability, what are some end-of-life options for asphalt and concrete pavements, and what are some strategies to improve end-of-life sustainability of asphalt and concrete pavements. Before we get into the end of life, we should learn why we should care about pavement sustainability. So from the program, we also developed the definition of sustainable pavements, which 1 is to achieve the engineering goals, 2, while preserving and ideally restoring surrounding ecosystems, 3, use financial, human, and environmental resources wisely, while meeting the basic human needs such as health, safety, equity, employment, comfort, and happiness. With that, we've focused on the triple bottom line, which is the benefits of being more sustainable and looking not only at the economic benefits, but also looking into the environmental and social, which include reducing of energy, noise, and improved air quality for environmental, and improved safety, right, and conservation of resources for the social benefits. Throughout this webinar, you will see that there are opportunities to improve sustainability throughout the pavement life cycle. Today's webinar will only focus on the end-of-life considerations. And with that, I would like to pass on the webinar to our first presenter, Mr. Tim Aschenbrenner, who Mr. Tim Aschenbrenner is a senior asphalt pavement engineer with the FHWA headquarters on the pavement materials team. Mr. Aschenbrenner specializes in asphalt pavement and materials as well as quality assurance. He joined Federal Highway in 2012 as a mid-career hire into the Resource Center, and prior to that, he was the Colorado Department of Transportation for 25 years, as the state materials engineer for 9 and the construction engineer for 3. With that, I'll pass on the microphone to Tim Aschenbrenner.
Okay, well, thank you, Monica. Before I get started, I just want to do a check. Monica and Kurt, can you hear me and can you see my slide? Hello?
Yes, Tim.
I can hear you.
We can see it, and your sound quality is good.
Okay, thank you. Just a little bit different than we did our practice with the changes, but yeah, I'd be glad to go over some of the end-of-life considerations on pavement sustainability. So pavement end-of-life, what is end-of-life? And I'll define it through some examples here. The primary categories are reuse, recycling, and disposal. And each one of these options has costs. There's economic costs and there's environmental costs. And these have to be considered on a project-specific basis. Life cycle assessment, LCA, that's how we evaluate the environmental impacts. And then I'd like to emphasize that having a long life pavement is a very important strategy to minimize end-of-life impacts. Deferring that end of life to a time out in the future is very important, and that involves building a structurally sound foundation that may involve just periodic functional renewals on the surface. That's a process that really reduces overall life cycle costs. Now, in looking at end-of-life considerations, there's several options or considerations to get a realistic input. Some of these are listed here, off-site or on-site. Off-site might be a plant located off-site. On-site could be different types of in-place recycling. Demolition and disposal costs, I think, are self-explanatory. That might include the tipping fees or the demolition cost. Transportation, we have to haul those, and I'll go over some transportation costs in a little bit. The intended use or applications also important. If you're going to use that material in the surface layer, in a base layer, or an embankment or fill, that impacts the processing of that material, as the quality needed is different in each one of those layers. So the quality is also a big impact as well. So on the previous slide, I just mentioned 5 of those end-of-life considerations, and here's one I'll go over just as an example. That's on-site processing. So for on-site, costs are generally lower. We're going to have reduced fuel because we're not going to be hauling the material, or at least not hauling it far. Certainly there's social benefits. Yourself and your neighbors always experience a lot of traffic delays going through a construction project, but it won't be as bad if the construction traffic itself is not causing those delays. So for on-site, there's a big social benefit for reduced traffic. And then the economic benefits of the material and processing costs right there on the project is substantial. So for pavement end of life, I mentioned the three options: reuse, recycle, and disposal. If we just discuss an example of the importance of reusing or recycling, the example here would be looking at depletion of quality aggregates. Depletion of aggregates is occurring. Even where I live, there's an aggregate source I'm familiar with that has built many projects. Well, now it's been reclaimed. It's a nice scenic lake. New aggregate sources aren't coming in very often. So we really want to reuse and recycle as much as we can. Theoretically or ideally, we might talk about a zero waste pavement construction stream. And that would mean as we have a pavement that's reached its end of life, and we're going to build a new pavement that's going to last for a long time, we want to make sure that we use all of those materials back in the new pavement. That would be a zero waste construction stream. Although idealistic, it's probably close to happening with several pavements now. So I think in pavements, we're being very conscientious in this area. So if we look at asphalt and concrete, RAP, the reclaimed asphalt pavement, or RCA, the recycled concrete aggregate, very little, if any, is going to landfills. It's being reused. About 99% of asphalt pavement is recycled or reused. In 2012, that was about 60 million tons. There's about 140 million tons of concrete, and that includes both pavement and demolition in 2014. This is a valuable material that is being reused often. Now, transportation is a big process, whether we're moving materials from a project site to a central plant or to a landfill. And you can see that trucking is the most expensive method. And when we do that, most often it's done by trucks. So really minimizing transportation of these materials is a key. As we look at reuse and recycling, we can try to optimize how much we reuse or how much we recycle. And to optimize, that includes economic, environmental, and social impacts that are done in a LCA or a life cycle assessment method. Clearly, we don't want to compromise performance. Now, we had a long-lasting pavement before. We want to make sure we have one again. But these tools can be used to do this optimization. One is life cycle cost analysis. That looks at the economic benefits and trade-offs. LCA, as I mentioned, the life cycle assessment, that looks at the environmental impacts. Then there's also sustainability rating systems that look closely at the environmental and social impacts. So that section was on pavements in general. Now I'm going to shift a little bit and talk about asphalt pavements specifically and end of life. And not surprisingly, we have the reuse, recycling, and disposal. Reuse, an example of that with asphalt pavements might be a perpetual pavement, for example, that has a strong foundation, perhaps a crack relief layer, and then a sacrificial surface layer that's milled and overlaid at periodic times. Recycling, examples of that could be in-place recycling with full depth reclamation or cold in-place recycling, or even at a central plant. And then disposal, although not preferred, we really don't see that much with these pavement materials because they have such a tremendous value. They're almost always reused and recycled. So for reuse, if we were to look at reuse and want to evaluate a pavement, here's a series of questions you might ask to see if it's appropriate to reuse. Some of the most important ones are, is the foundation providing adequate support? Is there a lot of patching or blowouts? How much repairs are needed? These questions can help guide if we're able to reuse or not. And if we are able to reuse it, some strategies with asphalt might be some corrective milling prior to an overlay, or perhaps there could be a concrete overlay to address load carrying capacity. Now, reuse may not be feasible. Sometimes there's those geometric and safety issues that develop. Could include clearances under overpasses, needing to change the alignment for clear sight distance, side slopes needing to be adjusted, and so on. But these are all factors that should be considered when you look at reuse. We're not always able to reuse, so a second option is recycle. And when we look at recycle, again, there's a series of questions you might ask yourself if you're going to use that material to recycle. Again, we don't want to compromise performance. We want to make sure we get that same long-lasting pavement whether we reuse or recycle. Hauling distances are a factor. We have to know what those distances are in order to do the calculation of the costs. Sometimes we need to ask if we can recycle that material in the future. Producing a mixture with RAP, say you're using RAP from a hot plant and you want to construct a new pavement, there's some factors there you have to consider in terms of the mix design. And also agencies have limits, and this is for good reason. Agencies often limit the amount to make sure they get the high quality pavement that will last a long time, and that could be limits in terms of the amount of RAP or things of that nature. And when we recycle, there's a couple of ways we can do that. One way shown here is central plant recycling. Could be a hot central plant, or as shown in the photo there, a cold central plant processing. And by central plant, what I mean is it's just a process where the asphalt mixture goes to a central location, could be combined with some virgin aggregates, maybe some new asphalt binder or recycling agents to produce the material or the paving material that's placed on the project. Most commonly it's done is hot central plant recycling. That's done in every state, and almost every project now is really using recycled materials. When RAP is used in the hot plant, the aggregates are superheated such that they can transfer heat to the RAP. This removes moisture and allows for mixing of the RAP. Key part is you got to make sure the moisture in that RAP is lower, because that will impact the amount of fuel costs. So RAP is done almost everywhere. Now, cold central plant, that's not as common. It is effective. I will say Virginia is one example. Just did an excellent job with some interstate pavements using this technique. No heat is used, but that reclaimed asphalt pavement, that RAP, is added with an emulsion, perhaps a recycling agent, and mixed in cold in a plant. Sometimes virgin aggregates needed if properties needed to be adjusted. And it can be used for bases, sub-bases, or even surfaces. Now, in doing central plant recycling, it's not like you can just do it. There's factors that you have to consider in order to make sure you get that long-lasting pavement. Sometimes when using high quantities of RAP, that reclaimed asphalt pavement is fractionated. It's put into different sizes. Each size is in its own stockpile. And that allows plant operators to make adjustments in the plant to make sure the overall mix has good quality. Dust control is another factor. When using RAP, more dust is often created, and that impacts the mix design because we want a quality mix design. And this could impact the voids in the mineral aggregate or the dust to binder content. Although a lot of plants have controls to control the amount of that P200 going back into the mix, it's definitely a consideration when looking at using RAP and the quantity of RAP being used. Now, in addition to the in-place, or in addition to using RAP at a central plant, there's also in-place recycling. And in-place recycling can include hot in-place recycling, cold in-place recycling, or full depth reclamation. This slide here talks about full depth reclamation, which I'll share as one example. And so for full depth reclamation, as shown in the photo there, a reclaimer pulverizes that existing asphalt pavement and a couple inches into the underlying base or sub-base to provide a homogeneous material. And then a surface course is placed on top. Full depth reclamation includes a reclaimer and then a nurse truck, typically with emulsion. Emulsion's added in there. And that process is extremely cost-effective and beneficial. As you can imagine, the material is right there on site, so there's no hauling, no purchasing new binder, no purchasing new aggregates, so there's reduced costs. It's very efficient in terms of time, so there's reduced time of lane closures. A lot of benefits with in-place recycling. A lot of the benefits are listed here. These can be project specific again, so I need to be looking at these on a project by project basis. There's some example limitations that may apply to some projects and may not apply to others, but they're things that really need to be considered when looking at full depth reclamation or any of the other in-place recycling processes. So what are some strategies to improve the end-of-life sustainability? And here I just like to highlight a reference document. It's on the FHWA website. It's called Towards Sustainable Pavement Systems, a reference document. So it's about 500 pages long, so it's not the type of document you'd read from cover to cover, but as the title says, it's a reference document. And if you want more on end of life, in chapter 8, there's about 32 pages. I'm just going to go over 3 strategies taken out of this reference document. So strategy 1 is that perpetual pavement, solid foundation, crack relief layer, sacrificial wearing surface. That meets the economic, environmental, and social benefits of longer lasting pavement. It's a very solid approach. Strategy 2, this would be increasing central plant recycling, for example, increasing RAP. So most all mixtures have RAP. Many of them have high RAP. But in this particular example, if you're going to go to extremely high RAP, over say 50%, there's clearly social and environmental benefits. But initially, if you try to ramp up to that high of RAP usage, there may be some costs that require improving the plant technology or equipment on the plant, or using softening or rejuvenating agents or things like that. Now, I will say those costs can be offset over time, and eventually there will be economic benefits with using those high RAP mixtures. And then the third strategy that I'd like to mention from that reference document is using in-place recycling more often. Clearly the social benefits with the faster construction and less hauling, the environmental benefits of reusing the material right there on site are present. I will say under the economic, there's no check marks. And maybe if you look specifically at having to add a stabilizer or adding a structural overlay, there may not be economic benefit. However, if you look at the overall process, if you look at overall in-place recycling, it is extremely economical, and looking at the overall system, I'd be checking all the economic boxes there. So again, I'd encourage you to check out that reference document. At this point, I'd like to turn it over to Rick Meininger. Rick is with FHWA's Turner Fairbank Highway Research Center. That's in McLean, Virginia. He's principally involved in concrete and aggregate research. He's been at FHWA for more than 15 years, and he'll discuss more regarding concrete end of life. Turn it over to you, Rick.
Okay, thank you very much, Tim. Let's get right into the end-of-life options for concrete pavements in this section. And as Tim mentioned, the 3 major options are reuse, recycling, and disposal. And the disposal option is not really preferred. We try to not contribute to various rubble landfills and that sort of thing. And generally, pavement materials can be reused in a number of ways. First is the major reuse category, and this is where the concrete pavement might be reused in its current form and placement, often with minimal repair or processing. Examples might be an asphalt overlay over concrete pavement, and in here you might use an inner layer of some sort to minimize reflection cracking. And then another option might be crack and seat. This has been used by some, where you would essentially break the concrete slabs and then build a new pavement over it, but it would provide a pretty good base for a new pavement. Another option might be an unbonded concrete overlay, and some states do this. Other states have been rehabbing concrete pavement by patching the worst spots, repairing joints, retrofitting dowel bars across transverse cracks, and then the pavement can be ground and grooved to improve rideability. Later, it could be overlaid. Next is recycling, and here we would be breaking up, removing the concrete slabs, crushing and processing the concrete to produce recycled concrete aggregate, RCA. And this has been used extensively in Europe since the 1940s and in the U.S. since the 1970s. And of course, any steel from any reinforcing that might be in the pavement or dowel bars must be removed. If there is reinforcing steel, you would need cutting tools and magnets and manual picking before it is finally crushed and screened for reuse. And of course, the steel can also be recycled at that point. The top figure shows an on-site recycling plant, which certainly is the preferred way to do it. If you can set up a recycling plant on the project, you know you have consistent concrete coming into the plant and can make a consistent product from it. A recent example I was reading about is LaGuardia Airport, where they have set up a RCA plant on the airport property to eliminate a lot of truck traffic through the local community, and that's apparently working out well. But in many urban areas, you don't have the luxury of doing that, and there are many local recycling operations. I'm fairly familiar with Houston, where virgin aggregates must come in by water or rail, in some cases fairly far away. So RCA is used extensively as pavement base. And these operations can take large slabs to be crushed for RCA, and then the same trucks can deliver RCA base course aggregates back to projects. Some can ship granular RCA base, and some also have a cement bin and pug mill, and they can load cement treated base back to the trucks, back onto the trucks for new bases. Going on to the next slide. Let me see, I'm trying to advance my slides here. It's kind of gone to sleep on me. There it is. I guess there's a little delay there. In slide 38, here are some considerations for concrete pavement reuse. And in this case, is an example in the picture of a badly deteriorated concrete pavement that had some joint deterioration and decracking. And apparently they were able to patch it up and then use it as support for a unbonded concrete overlay with a separation layer to make sure the cracking was not reflected back up through the new pavement. So even seriously deteriorated concrete pavements have been successfully reused with unbonded concrete overlays. Other things might be to in terms of considerations of whether you could reuse the existing pavement are things such as, will the old pavement provide uniform support? Does the pavement does the pavement have correct drainage, or will there have to be some sort of geometric realignment of the pavement, or reworking of shoulders and some of the guardrail configurations? This can all enter into the decision of whether you can reuse a pavement in place. Another consideration is whether you're going to use recycled aggregates, RCA, or whether you're going to use virgin aggregates. And it may boil down to some of the local considerations, what local aggregates are available. If there are quality local virgin aggregates nearby, that may be the best option. In other cases, where the virgin aggregates have to be hauled in from quite far away, then you would look at using recycled material, perhaps trying to upgrade some local aggregates as well, or coming up with a blending option of some sort to best use the local materials. And anytime you recycle aggregates, you want to make sure that the aggregate is not going to undermine future recycling operations. Does it have steel fiber in it, or some other consideration that may make it very difficult to recycle? Let's go on to the next slide. Some of the considerations in pavement recycling are indicated in this slide. Recycling old concrete produces an aggregate that can be used in many applications. And typically it's used more in granular base and sub-base applications. That's the typical use these days. But it can be used in new surface layers. If it's of good quality, it might be used as aggregate back in a new concrete pavement, or it might be used as aggregate in an asphalt pavement. There have been a few pavements built with a two-layer concept where the lower quality RCA aggregate or local aggregates is used in the lower layer of the concrete, and then a new layer of concrete is placed wet on wet concrete on top of the recycled aggregate layer, and you get very good bonding, and the aggregate in the top layer would be of higher quality. And so this has been done, and was done, for example, on the Illinois Tollway, and there was a demonstration project on I-70 in Kansas that used recycled aggregates in that way. Another consideration about recycled aggregates is that you can get some runoff or drainage effluent from the material, and it's essentially from the calcium hydroxide from the old cement in the RCA, which consists of aggregate plus mortar. Generally, that calcium hydroxide will make a high pH runoff, but generally when it's exposed to air, it will fairly quickly neutralize to a lower pH, and typically not a problem, but some states in addressing this issue will require certain kinds of treatment. Another thing in recycling aggregate back into new pavement, in general, you don't want to use a pavement that has had ASR or decracking back into a concrete pavement. It would be better used as a granular base course. Next slide slide 41 discusses the fact that if you're using recycled concrete aggregate back in new concrete, then you'd want to measure the physical and mechanical properties of the RCA concrete and design the pavement accordingly in terms of the pavement thickness and the necessary base properties so that it will perform well. Also, you need to give consideration to the fact that you would probably get a little lower strength because of the nature of the mortar and aggregate. And we've done a little work in our laboratory doing petrographic work on RCA materials. And typically you will have a higher porosity, and that needs to be taken into consideration both for strength and durability. The higher absorption capacity of RCA often results in higher water demand and more rapid stiffening of concrete. It's very important to pre-saturate RCA coarse aggregate prior to mixing, and normally RCA fine aggregate is not used back in concrete because of the high mixing water demand. But all of the RCA aggregates can be used in dense graded bases or in cement treated bases as well. Let's go on to the next slide. What are some of the strategies to improve end-of-life sustainability of concrete pavements? Going to take a look at a couple of these strategies. As Tim mentioned, when we're looking at strategies, we would look at the cost or economic basis. We would also look at the environmental effect of the different materials that are being used and how long the particular pavement will last. And then we also look at the social considerations as well, like noise, dust, truck traffic, those kinds of things. How well will it serve the community that you're building it in? So strategy number one that we have here on this slide is design concrete pavements to be a longer life pavement. In this case, you would minimize the stresses and extend the pavement service life, and therefore repaving or rehabilitation is put off for a number of years, and that certainly is an advantage. To do this, you need to use durable materials, increase the initial smoothness of the pavement so that it lasts longer, employ non-erodible base layers and good drainage, consider a widened slab or tied shoulders for better heavy truck loadings. There are a number of states that are also now using continuously reinforced concrete pavement. And of course, these are generally built fairly thick with the steel reinforcing at about mid-depth, and they will last quite a long time if you use durable materials. So this is certainly an option for a longer life pavement. And as Tim mentioned, Chapter 8 of the Sustainable Pavements reference documents has much more detail on these different strategies. Strategy number 2 is to optimize the use of the RCA. So you would want to adjust the RCA production operations for the particular use you're going to use it for. And of course, this would be a lot easier in an RCA crushing plant that is dedicated to a particular project. If, on the other hand, you're doing urban recycling, then the quality of the RCA is probably going to be reduced due to the fact that concrete comes from a number of different sources, and typically that may only be used in granular base or the cement treated base option. customize the preparation and breaking of the source concrete. In other words, try and break up the concrete in the most optimal way so that the crushing and screening operations will go smoothly. And as I mentioned before, using the RCA in the bottom layer of a two-lift Portland cement concrete pavement, that's certainly an option to optimize the use of the RCA. In one of the Illinois toll road projects that I'm familiar with, they were actually using some of the coarse recycled wrap from asphalt pavements back in concrete pavement in the lower lift. The wrap did not have much asphalt content on it, and it met the strength and durability requirements for the project. Strategy number 3, reduce life cycle. This one just points out that when you crush and recycle concrete, the material absorbs carbon dioxide emissions from the atmosphere, and this, of course, helps reduce CO2 levels. It's actually reclaiming some of the CO2 that was emitted when the cement was originally produced. And this graph just shows how the CO2 is absorbed into an RCA aggregate with time. And, you know, even in 10 hours in a couple of these cases, the CO2 was being absorbed fairly rapidly. And of course, this would tend to make, when CO2 reacts with calcium hydroxide, it makes basically limestone calcium carbonate. So it's a good material. The next slide is we're going to do just kind of an overall summary here of what we've been talking about with the end of life webinar. And some of the general key takeaways are that what the options depend quite a bit on the type and quality of materials used in the pavement design, and whether that particular pavement is a long life design, and maybe all you have to do is put a new wearing surface on it and not have to disturb the strength of the foundation itself, and the construction quality. Obviously, a better constructed pavement is easier to either reuse or recycle. In terms of reusing the existing pavement, if you can do that where possible, that certainly saves a lot of energy and time. And when you do recycle the pavement, on-site processing is preferred over having to haul the material back to a crushing plant and then bring the material back to the project. Another general key takeaway is many recycling and reuse options are available. And in general, each option is site specific, and it depends on the particular project that you have. It varies with the availability of materials, processing options, new pavement requirements, and construction scope. Assess the performance and economic and environmental and social aspects. So with sustainable pavements, we always want to look at the 3 aspects of economic, environmental, and social impacts. But we always want to make a pavement that's going to perform well and will last for a long time. In terms of asphalt pavement end-of-life sustainability, Tim talked about using improved plant technology so that recycling can be done more efficiently, improve the initial quality of the recycled product. In other words, don't try to mix good quality wrap with other wrap that might have been contaminated or is from poor quality pavement. Use rejuvenators or softening agents. Make sure your mix is properly designed for the recycling that you're doing. Maintain and manage your wrap stockpiles and try to, again, minimize poor quality material getting mixed in. And select the proper type and amount of stabilizers and consider structural overlays. Consider the structural strength of the existing pavement as well as the strength of the overlay that you're putting on so that the pavement is designed properly for the application. In terms of concrete pavement, end-of-life sustainability, you want to optimize RCA production operation based on the intended use, customize the preparation and breaking of the source concrete, and also consider in your environmental considerations the fact that you are sequestering some CO2 in the operation. And give consideration to using RCA in the bottom lift of two-lift PCC pavement structures. Now I'd like to turn it back over to Monica Duardo. She's going to give some examples of some of the FHWA products and some of the things we're doing. Thank you.
Thank you, Rick and Tim. So with that, we have some guide documents, which the first one would be the Towards Sustainable Pavement Systems. We also have the Pavement Lifecycle Assessment Framework, along with some technical briefs, anywhere from pavement sustainability to strategies for improving sustainability of asphalt and concrete pavements. We also have the webinar series previous to this one, and we also have the recordings for this webinar series. And we also have our Sustainable Pavements Program Roadmap. All these, and if you want to learn more, please join us next month for our Life Cycle Cost Analysis Part 1 Fundamentals webinar, which will be on April 16th at the same time, 2:30 to 3:30 Eastern Time. For more information, please visit us on our website, or if you have any questions or comments, please feel free to contact Heather Dillo or myself, Monica Jurado. And with that, I'll open it up for questions.
All right, this is Kurt Smith again, and we thank our speakers for sharing that background information on end of life. We do have a few minutes now to go through some of the questions, and again, you are welcome to submit your questions using the control panel on the webinar setup. We'll try to get through as many of these as we can, but those that we do not get to, our speakers and attendees here today will have the opportunity to prepare some responses, and we'll share those with all participants. So let's first start in. I got just a general question. We'll start with Tim. Tim, just a general question, and maybe it might be good just to kind of revisit this a little bit. The question is, why do we call it end of life when we're actually reusing the pavement to become a new pavement? So maybe just kind of expand on that a little bit.
Okay, yeah, sure, Kurt. Yeah, it could be more of a matter of semantics, but I guess you would look at a pavement and it's reaching the end of its life. It's lasted a long time. It's done its service. And maybe by definition, we're calling it end of life. It's probably at a point where some people might consider it's time to take it out and dispose of it or demolish it, say like a building, for example. We don't often see that. More often with pavements, we see it being reused or recycled. So without getting too much into the semantics, I guess we call it end of life because we're at that critical decision point where we're trying to decide what the next step is, which often involves maybe some combination of reusing and or recycling.
All right. Thank you, Tim. And now let's jump over to back to Rick. Rick, kind of a two-pronged question here. First of all, should you recycle concrete pavements that have ASR, alkali silica reactivity? And what about concrete pavements that perhaps used aggregate slag?
Yes, in terms of alkali aggregate reactivity, I think it could be used as a granular base because there would still be space for the expansion, and if some of the particles crack more, then that probably won't be a problem in a granular base. But I would not use an ASR back into new concrete pavement. With respect to slag aggregates, that's somewhat of a special circumstance. They tend to be more porous. I think you would want to do some trial mixtures with that. You might also, the National Slag Association has a great deal of technical information as well. So I think it would need to be considered on a specific project basis.
All right, very good. Thank you, Rick. Let's go back to Tim, and just again, kind of a general question, Tim, maybe worth repeating or perhaps just clarifying a little bit, trying to understand the difference between reuse and recycling of a pavement. Maybe we can try to draw the distinction a little bit between those two.
Okay, sure. Yeah, reuse and recycling. Yeah, oftentimes it's not really one or the other. They're not mutually exclusive. But generally speaking, reuse is when majority of that pavement stays in place as a strong foundation. The majority of the pavement is in solid condition. There might be some rideability concerns, maybe a little bit of patching, but not too much. And so you can reuse a majority of the structure as is, perhaps with just some corrective milling of the surface and an overlay. So by doing that, you're also recycling. So as I said, reuse and recycling are not mutually exclusive. Sometimes they're done in combination and you can optimize that. Whereas reuse, probably that would be more to the case where you're doing more recycling. You're taking up the pavement more to use as a wrap through the hot plant, or you're doing a more in-place recycling. Majority of the pavement is recycled in that manner. Yeah, so reuse and recycling, it's usually not one or the other. There's oftentimes a combination.
All right, great. Thanks for the clarification, Tim. Let's go back to Rick. Rick, there was talk about using reclaimed asphalt pavement in concrete. One question we have is, can we use recycled concrete aggregate in asphalt? And actually, this might also be something that Tim could weigh in on as well.
Yes, I think it certainly can. The problem is that it tends to have a higher absorption of asphalt, and that may be an economic issue. But on the other hand, the asphalt may stick to the RCA aggregate fairly well, and I have known of several cases where they did use RCA aggregate back in an asphalt mixture.
All right, Tim, anything that you might want to add to that?
Yeah, the only thing I'd agree with Rick, it's probably not common because asphalt's a very expensive ingredient, and the absorption into the recycled concrete aggregate doesn't use that asphalt most effectively. I guess when I have seen it done, it's in areas of the country that may be challenged in terms of getting good aggregates. Maybe they have to have not locally available, but maybe they have to come in via barge, or aggregates have to be shipped in. And in those cases, it may be cost effective to use recycled concrete aggregate, but it's not common, only in unique situations.
All right, thanks. And Tim, as long as we've got you on the floor here, there's a question about the type of rejuvenators that are commonly used for recycling and whether there are any specifications for those.
Yes, so I guess the umbrella term that we commonly use is recycling agents. And then under that umbrella, there's a category we'll call rejuvenators. And rejuvenators actually will restore the flexibility of that asphalt binder. It'll actually restore asphaltenes and maltines. Rejuvenators are very expensive, but they also do more to bring that aged binder back to where it needs to be. And then under the umbrella recycling agents, not only is there rejuvenators, but then there's also softeners. And then softeners pretty much just soften the asphalt, but don't really give the asphalt its characteristics back. So most commonly in recycling, we'll see the use of softeners, with rejuvenators being so expensive, it would take away from the cost benefit. I think in in-place recycling, we see a lot of emulsions commonly used, or things of that nature. I guess I can refer to some ASHTO standards that were just published as part of the in-place recycling, and there's some guidance there. So without endorsing or without mentioning anything specifically, for that reason, softeners can often do a great job.
Okay, great. Thank you. Let's go back to Rick. Rick, this question is talking about the source of materials, and I think the reference is to the source of recycled materials, and particularly, is there a difference between, for example, recycling concrete pavement and, say, building demolition? So could you maybe speak on the use of some of those recycled products and their appropriateness for use as a recycled material for pavements?
Yeah, certainly. In some of these urban recycling plants, they do receive concrete and sometimes other debris, tile and brick and so on and so forth, that gets all mixed up in the crushed RCA, but usually most of it is concrete. But it comes from a variety of different demolition sites, from buildings, sidewalks, curbs, various pavement slabs, etc. So it's much better if you're recycling concrete if you have a known source. For example, the O'Hare Airport has been realigning some of their taxiways and runways, and they have set up RCA crushing plants there. And in that case, typically a concrete pavement from a state DOT or from an airfield pavement, if it doesn't have a deterioration problem, it's of very good quality, and you can make a pretty consistent RCA from it. But with the urban rubble recycling, it can be a little hit or miss, and you will get other materials mixed in, and that's where one of the reasons that it's usually used as either granular base or cement treated base.
Great. Thank you, Rick. So thank you again for your time and attention. We hope you found the webinar informative, and we look forward to having you attend our next webinar presentation, which is scheduled for April 16th. So thanks again, and stay healthy, everyone.